Hey guys, I hope you are all doing well. Welcome to my channel Beloved Academy.
In today's video, we are going to be learning the concept of linear programming. In my previous video, I show you how to solve linear programming problem using the graphical method, and the one that I solved using the simplex method is two variables. But in today's video, I'm having three variables and three constraints. We are going to be using the same approach, but this is a bit little complex compared to the one that I first solved. So I want you to follow me carefully. This is the question that they gave us to solve. As you know, in linear programming, we will always have an objective function and we always have the constraint. So therefore, this is the question, this is the objective function here, and this is the constraint that we have. If you want to solve this problem, the first thing to do, in my previous video, I told you that is to change this constraint and the objective function into standard form by introducing a slack variable. The work of the slack variable is to absorb those resources that is unused. Therefore, if I want to introduce this slack variable, you are going to look at the numbers of your constraint to know the numbers of slack variable that you are going to be introducing. For example, in this case, I have three constraints. I have constraint 1, constraint 2, and constraint 3. Therefore, I'm going to be introducing three slack variable. So, in order to change this to standard form, I'll be changing this objective function to standard form. For the objective function, I have 50xi z is equals to 50 x1 plus 48 x2 plus 90 x3. Now, the slack variable that I'm going to be introducing, we take the values of x4, x5, and x6, one for each constraint that I have here. So I'm going to be having plus 0x4 plus 0x5 plus 0x6. I've already changed this to standard form. I have changed the objective function to standard form. Now, the next thing I'm going to be doing is to change the constraint also to standard form. For the constraint 1, because the slack variable x4 belongs to constraint 1, I'm not going to be the coefficient of x4, the coefficient of slack variable x4 will take a significant value of 1. The coefficient will not be 0. When I want to change this to standard form, for example, watch this video carefully. For example, in this place, the objective function, all the slack variable that I introduced take the values of 0. But when I want to deal with the constraint, each slack variable belongs to each constraint. Therefore, the slack variable, we assume that the slack variable that belongs to a particular constraint will not take the coefficient of 0. Therefore, for this one example, okay, now for this objective function, I'm going to be having 2x1 for the first constraint, 2x1 plus 2x2 plus 2x plus x4. Because these belong to this constraint, so I'm not going to put 0 as the coefficient, but the other slack variable, the coefficient of the other slack variable will be 0. So I'm going to be having plus 0x5 plus 0x6. For the second slack variable, I'm going to have 6x1 plus 4x2 plus 9x3 plus 0x4, because slack variable x5 belongs to this constraint. So I'm going to be having 1 as its coefficient here, 1x5 plus this will be 0x6. Now, for the third constraint, I'm having 9x1 plus 8x2 plus 12x3 plus 0x4 plus 0x5 plus 1x6, because this slack variable belongs to constraint the third constraint. The third slack variable, which is x6, belongs to the third constraint. Therefore, I'm going to be having 1 as its coefficient. Now, you have already changed the, okay, let me have 16, 36, then 60. Now, you have already changed the objective function to the objective function and the constraint to standard form. The next thing to do is to prepare your initial simplex tableau. As you know that we are going to be using simplex method to solve this linear programming problem. Trust me, the process is very, very interesting. Just follow this video carefully. This is how the simplex table will look like. In this simplex table, I have the resource in here, the real activity level, the real activity, the slack activity, and the fraction. This is how you are going to prepare your initial simplex table. The reason why we have to prepare this is because we have to determine our key elements, and we have to determine our key column, and we have to determine our key row. Therefore, For the reactivity level, the reactivity level will be the output of each constraint. For example, in this place, I have 16, 36, and 60. So for this one, I will have 60, 16, 36, and 60. And for the real activity, what I'm going to be having here, I will look at the coefficient of my x1, x2, and x3 on the constraint. I will look at the coefficient and then put them there. For example, in constraint 1, I have the coefficient of x1 as 2, so I'm going to have in 2 here. For constraint 2, I have 2. For constraint 3, I have 2. For constraint 4, for constraint 1, for x4, I have 1, and for x5, I have 0, x6, 0. Also, in this place, I have the coefficient of x1 in constraint 2 is what? 6. So I'm going to be having 6 here. For coefficient of x2 in constraint 2 is 4. For x3, I have 9. For x4, 0. For x5, I have 1, and for x6, I have 0. Then for constraint 3, I'm going to be having the coefficient of x1 in constraint 3 is 9. The next 8, the next is 12, the next one is 0, then for the next one I have 0, then I have 1. If you look at this reactivity level, I told you that this constraint 1, the slack variable that belongs to constraint 1 is x4. Therefore, you are going to go to your objective function and write out x4. So x4 belongs to this place, and x5 belongs to this place, and x6 is for this constraint, is for the third constraint. Now go to your objective function, look at the coefficients of x4, x5, and x6 that is there. They are both 0, so you are going to be having 0, 0, 0 as the coefficients. Now this is your prepared initial simplex tableau. Now the next thing that you have to find is to find the value of your zj and find the value of your pj minus zj. But you cannot find the value of pj minus zj without knowing the value of your pj. The value of your pj will be the coefficient of the objective function itself, and the coefficient of the objective function is, for the x1 I have the coefficient as 50, so I'm going to be having 50 here. For the x2 I have 48. For the x3 I have 90. For the x4 I have 0. For the x5 also 0. For the x6 also 0. So therefore, this is the value of my pj. Now I can proceed to find the value of zj. For example, now if you want to find the value of zj, you have to take into consideration each column. You have to take into consideration each column. For example, for column x1, if I want to find the value of zj in column x1, you know that the coefficient of x4, the coefficient of x4 in my resource level is 0. Instead of x4 here, I'm going to be inputting the corresponding value of x1 in this place. The corresponding value of x1, for example, if I want to find the value of zj for this column x1, what I'm going to be doing is that I'm going to write this out. For example, this is what? 0. Instead of this x4, I will trace it. The corresponding element will be 2. I have 2 here plus. Then go back to your second constraint, which is I'm going to be having another one, 0. Trace it to that column. You are going to trace it to that column. That is 6. So I'm going to be having 0 into bracket 6 plus another one for the resource that is here. I have 0. So I will trace it to the column that I'm solving for. So that is 9. Now 0 multiplied by 2 multiplied by 6, 0 multiplied by 2 will be 0, 0 multiplied by 6 will be 0, and 0 multiplied by 9 will be 0. So the value of my zj for this place is 0. So I have 0 here. That is how we are going to calculate for everyone. For the second column, I'm going to be having 0 multiplied by 2, that is 0, 0 multiplied by 4, that is 0, 0 multiplied by 6, that is 0. So for this place also, I'm having 0 in this place also. For the next column, I'm going to be having 0 multiplied by 2, that is 0, 0 multiplied by 9, that is 0, 0 multiplied by 12, that is 0. So for this place, I have 0 also. If you do it for everyone, you are going to be having 0, 0, 0. Now, you have gotten the value of your zj. Now, we are going to get the value of pj minus zj. As you know, you have the corresponding pj here and you have zj here. What we're going to be doing is to subtract pj and subtract it from the value of zj that you have here. The value of pj is 50 and the value of zj is 0 in this place. So I'm going to be having, for this column, the pj minus zj will be 50 minus 0. So I will have 50 here. 48 minus 0, that is 48. 90 minus 0, that is 90. 0 minus 0, 0, 0, and 0. Now, I have gotten the value of my pj minus zj. in order to get my key column, if you look at this value, the highest of all the value, the column, the highest of all the value of my pj minus zj, the column to which the highest element belongs to, that will be my key column. If you look at the pj minus zj that I have here, you will realize that the highest value is 90. Therefore, my key column will be here. I'm going to be circling from this place. This will be my key column because the highest value of pj minus zj is 90, and 90 is greater than 50 and 48. Therefore, my key column is here. Now, I have gotten my key column. In order to get my key row, I will have to divide the element, the real activity level, divided by the corresponding element in my key column. Then after getting my key row, the elements that intersect both the key row and the key column will be my key elements. Kindly follow me carefully. You look at this is the real activity level. I have 16 here. If you look at this, you will see that the corresponding element is 2. Therefore, for this one, I'm going to be having 16 divided by 2. 16 divided by 2 will give me 8. So I'm going to be having 8 here. That's the fraction. 36 divided by 9. That will give me 4. 60 divided by 12. That will give 5. Now, you have gotten the value of your fraction. Now, if you want to get your key row, you have to look at this value. In this fraction column, we have 8, 4, and 5. The least positive value among these three, the row to which the least positive value of your fraction belongs to, that will be your key row. For example, in this place now, I have the least positive value here is 4. Therefore, I'm going to be having 4 as my key row. My key row is this place. I'm going to be circling from here to here. So this is my key row. Now you can assume that the element that intersects both the key row and the key column is 9. You can see here the element is 9. So my key element is now 9. My key element equals to 9. You can see that the value of my pj minus zj, I still have positive value. For me to obtain the optimal solution of the linear programming question that they gave me using simplex method, the value of my pj minus zj must be less than or equals to 0. When the value of my pj minus zj is less than or equals to 0, then I have already attained an optimal solution. But if you look at the pj minus zj in here, you will see that I still have positive value, and the positive value that I have, they are even greater than 0. So therefore, this is not my optimal solution. I'm going to proceed with the calculation, and that will give birth to the first iteration. This is the newly constructed table that I have here. However, you can also join this table with this table, but I want it to be simplified so that you can understand. That's the reason why I separate it. As you can see, all the parameters that I have in the first table, that's all the parameters that I have in this second table. But only the thing that we're going to be changing there is the element of the table. So therefore, let us proceed. Don't forget that the value of our pj is the coefficient of the objective function, and I have it here. The coefficient of x1 in the objective function is 50, so I'm going to have 50 here. For this one, I have 48. For x3, I have 90. For x4, I have 0. For x5 is 0. For x6 is also 0. Therefore, now I want you to take notes. Don't forget that the key element is 9. Since I know that the key element is 9, there is something called leaving variable and entering variable. You can see here, if I trace this column where my key element belongs to, if I trace it to the top, you will realize that the variable that is there is x3. And if I trace the column, the row whereby my key element belongs to, if I trace it to the left hand side, you will see that the variable that is there is x5. Now, the leaving variable will be x5. x5 will be excluded now, and x3 will be entering. Therefore, I'm going to be having for the first column here, I'm going to be having x3 as the first column, x3. Now, I want to get the new value of my key row. As you know that the key row is here, I have to get the new value of this key row, and if I want to get the new value of this key row, the only thing I have to do is to make this element 1. I should do something. I should change this key element to 1. If I want to change this key element to 1, I have to divide the key element by itself, and if I divide the key element by itself, it has to affect every other element. So I'm going to 6 divided by 9, that gives 4. 6 divided by 9 is 2 over 3. 2 over 3. 4 divided by 9, that is 4 over 9. And then x3, 9 divided by 9, the key element divided by the key element itself. So I'm going to be having 1 here. For x4, 0 divided by 9, that is 0. And for the x5, 1 divided by 9, that is 1 over 9. And x6, 0 divided by 9, that is 0. Now, if you go back to the objective function, the coefficient of x3 in the objective function is 90. So I have 90 in this place. So I have gotten the new value of the key row, which is this. I've gotten the new value for this row is this. So therefore, I'm going to be getting the new value for the both row, which are 0x4 and 0x6. Don't forget, I'm going to be having 0x4 here and 0x6. The reason why I changed the position of my key row, because the key row falls to the second row in this table. The reason why I change it is for easy computation. So the next thing is to get the new value of each row, for this row and for this row. Now if you want to get the new value for this row, let's start with this row, this 0x4. You know that this is all the elements, the old value for this row 0x4. Now the formula for calculating this is the new value equals to old value minus corresponding key row elements multiplied by corresponding key column elements all over key elements. This is the formula for calculating the new value for these cells. Now let's proceed. Let's start with 16. To get the new value of 16, we are going to be having new value is equals to old value is 16 minus the corresponding key row element here is, you trace it back and you trace it downward rather. The corresponding key row element is 36, because this is our key row. So the corresponding key row element is 36. 6 minus in the bracket 36 multiplied by the corresponding key column element. You trace the element that correspond to the key column where 16 falls into. So if you trace it like this, you are going to realize that the key column element is 2. The corresponding key column element that correspond to 16 is 2. So I'm going to have 36 multiplied by 2 all over 9. So for this one now, I'm going to be having 36 multiplied by 2. That is 72. 72 divided by 9. That is 8. So 16 minus 8. 16, I'm going to be having 16 minus 8. 16 minus 8 is 8. So therefore, for the new value for 16 in this place, I'm going to be having 8. The new value of 16 now is 8. Now let's proceed to get the new value of 2. I'm still going to be using the same formula. The new value of 2 will be the old value, which is 2 itself. The new value will be 2 minus the corresponding key row element is 6. When you trace it downward, the key element that falls where 2 lies is 6. So the corresponding key element is 6. 6 multiplied by, if you trace it, the corresponding key column element is 2. So I'm going to have 6 multiplied by 2 all over key element, which is 9. So I'm going to be having 2 minus 12 over 9. 2 minus 12 over 9. So if you find the LCM, you are going to be having 9 multiplied by 2, 18. 18 minus 12 over 9, that is 6 over 9. 6 over 9 is equals to 2 over 3. So therefore, the new value of these two in this table will be 2 over 3. So I've gotten the value for these cells. The new element of 2 is 2 over 3. Now, if you want to find the new element, the new value for these two also, as you can see, this is the new value for 16 is 8. The new value for 2 is 2 over 3. The new value for these two also is also follow the same approach. You are going to be taking these two, subtract from the corresponding key row element is what? 4. The corresponding key row element is 4. So instead of 6 here, I'm going to be having 4. The corresponding key column element, the corresponding key row element is 4. The corresponding key column element is 2. You can see if you trace it back here, you are going to be having 2. So the corresponding key column element is 2. So I'm still going to be having 2 here divided by the key element. So divided by the key element. So I'm going to be having 2 minus 4 times 2 is 8. 8 over 9. So if I find the LCM is 9. 9 divided by 1, that's 9. 9 times 2 is 18. 18 minus 8 all over 9. 18 minus 8 is 10. So I'm going to be having 10 over 9. 10 over 9. So the value of this, the new value of these two, the new value for these two is 10 over 9. So that is how you are going to get the new value for all your elements. You are going to fill this cell using this formula that I provided. If you use this formula correctly, you are going to get accurate answers. These are the values that you are going to be getting. For example, let us test for another one now. Let me try to find, okay, let's find the new value of 8. Let's find the new value of 8. I want to test the formula. Now, if I want to find the new value of 8, the new value for this 8, the corresponding key row element is 4. I'm going to trace it to the top, which is what? That is 4. I'm going to be having 8 old value minus corresponding key row element. If I trace it to the top, the key row element is 4. So I'm going to be having 4 multiplied by, now the corresponding key column element, as you know, this is my key, this is my column, this is my row. So if I trace it to this side, the corresponding key column element is 12. So I'm going to be having 4 multiplied by 12 all over 9. Now if I proceed, I'm going to have 8 minus 4 multiplied by 12 all over 9 is 48. I'm going to be having 48 all over 9. So if I take the LCM is 9. 9 times 8 is 72. 72 minus 48. That is 24. So 24 all over 9. 24 divided by 9 can be reduced to 8 over 3. 8 divided by 3. So that is why I have 8 over 3 here. If you use this approach for all the elements in these cells, we are going to get their new value as this. Now let us proceed to find the value of our ZJ. We are still going to follow the same approach that we follow here. Look at this. We have 90x3 plus 0x4 plus 0x6. Now, if I want to find the value of the ZJ for these cells, I'm going to look at the corresponding value, the corresponding element that falls into where 90 is. If I trace this value here, you can see that the corresponding element is 2 over 3. So instead of this x3, I'm going to be substituting 2 over 3. Now I'm going to be having 90 into brackets 2 over 3 plus 0. Because 0 is the coefficient of x4 here, I'm still going to trace the element. The element is still 2 over 3. So 0 into brackets 2 all over 3 also plus 0 into brackets. Now I'm going to go back to my cells of x6. The element that correspond to it, that is 1. So I'm going to be having 0 into bracket 1. Now 90 multiplied by 2, that is 180. 180 all over 3 plus 0 multiplied by 2, that is 0. 0 divided by 3, that is 0. Plus 0 multiplied by 1, that is also 0. Now 180 divided by 3, that is 60. So therefore, the value of my BJ in this cell will be what? 60. I'm going to be having 60 plus 0 plus 0, that is 60. So the value of my PJ here is 60. 60. Now, if I want to find the value of the PJ for this column x2, I'm still going to be using the same approach. Okay, now, the value of PJ for column x2 will be 90. 90 into bracket. We are going to trace the corresponding element of x2, that is 4 over 9. 90 into bracket 4 divided by 9 plus 0 into bracket. We are going to trace the corresponding element that belongs to column x2, that is 10 over 9 into bracket 10 over 9 plus 0 into bracket. Now you are going to trace the corresponding element that belongs to column x2, that is 8 over 3. So 0 into bracket 8 over 3. If you punch your calculator, 90 multiplied by 4 divided by 9, that is 40. 40 plus 0 plus 0. So the value of pj in this column is 40. So that's how I'm going to be getting the value of the pj for this row, and for this other row, like that. So if I proceed, I'm going to have, for this one is 40, for this one it will be 90, for this it will be 0, for this also it will be 10, for this column x5 it will be 10, and for the last column it will also be 0, because by the time I multiply 90 multiplied by 0, that will be 0, and 0 multiplied by 0, that will be 0, 0 multiplied by 1, that will be what? 0. So the next value we are going to be getting is pj minus zj. As you know that we have our pj here, which is the coefficient of the objective function. So therefore, if you have this 50 from 60, that is minus 10, 48 minus 40, that is 8, 90 minus 90, that is 0, 0 minus 0, that is 0, 0 minus minus 10, 0 minus 10, that is minus 10, this one also minus 10, 0 minus 0, that is 0. Now, don't forget the condition of our optimal solution. I told you that the condition for our optimal solution is that the pj minus zj must be less than or equals to 0. If you look at the pj minus zj that we have here, you will see that from this value, we still have a positive number. Though the first column we have minus 10, the other column we have 0, 0, 0, but we still have a positive number, which is 8. Therefore, this is not our optimal solution. Therefore, I'm still going to proceed to the another iteration, that will be iteration 2. So from this point, I'll be using, since 8 is the maximum value of my pj minus zj, the key column will now be, the key column here will be this, because that is the column with the highest value of pj minus zj, that is 8. So the key column will be column x2, that is this. Now I've circled the key column. Now we have to look our key row. If you want to find your key row, we are still using the same approach. We are going to divide the resource, we are going to be dividing the real activity level divided by the corresponding key column element. The real activity level here is 4. So, and the corresponding key column element is 4 over 9. Now, if I want to get the fraction now, I'm going to be dividing 4 divided by 4 over 9. Let me put it here. 4 divided by 4 over 9. 4 over 9. That is 4 multiplied by 9 over 4. 4 here, 1, 4 here, 1. So I'm going to be having 9. So for this fraction here, I have 9. No, that is 9. Now, 8 divided by 10 over 9. That is 72 over 10. 72 over 10. Then for the next one, I have 12 divided by 8 over 2. 12 divided by 8 over 3. This is 3. It's not 2. This is 12 divided by 8 over 3. That is 9 over 2. So 9 over 2. Now you have gotten the fraction. You are going to be choosing the least positive value here. So the least positive value is 9 over 2, because by the time you change this to fraction, you realize that this is 4.5, 7.2, and this is 9. The least positive value is 9 over 2. So therefore, this row will be my key row. This row will be my key row. So this row will be my key row. If you look at the element that intercepts both the key column and the key row, the element is 8 over 3. So my key element will be what? 8 over 3, as I've written here. Now, as you can see, I told you that before we can obtain an optimal solution, the value of our pj minus zj must be less than or equals to 0, as I've written here. Now, if you look at the value of pj minus zj in this column, in this row, you can see that I still have a positive 8. Therefore, this is not an optimal solution. This is not the solution that we are asked to find. So I'm going to be having another iteration. I'm going to be having a table, and I'm going to be having another iteration. Therefore, we just have to follow the same approach that I've described in the previous step. So I'm going to be having another table now. I'm going to be having another iteration. This is the table for my third iteration. Don't forget that the key element that I got here is 8 over 3. Now, don't forget our approach. I told you that, look at the column here, the key column. The key column is column x2. To raise this column to the top, the variable that is there is x2. So since you know that the variable that your key column is pointing to is x2, so in this case now you are going to be having x2. Now I told you the concept of leaving variable and entering variable. X2 will be our entering variable. If you trace it downward, this is the key element. So if you trace it downward, x2 will be entering, why 0x6, x6, the variable x6 will be leaving the column. So I'm going to be having x2 instead of x6 in this place. So that's the reason why I wrote x2, and I prefer to make the row where my key element falls to, I prefer to make it to make it be the first row in my next iteration, so as to enhance easy solving of this question. So now you have gotten that the entering variable is now x2. Now go back to your objective function. The coefficient of x2 in the objective function will be the coefficient in this place also. So if you trace it, you are going to realize that it is 48. So I'm going to be having 48 in this place, 48. So that is 48x2. Now approach. You are going to get the third iteration as, you are going to get this value in the third iteration. You know, after getting your key element, divide this row by 8/3, which is the key element. We are going to get this row. After dividing, use the formula that I gave you earlier, that is the new value, old value minus the corresponding key row, multiply by corresponding key column, all over key element. You are going to get the value of these cells. Then still the same step, just follow the step that I used in this place. You are going to get the same answer. Now let's calculate the pj minus zj. For this one, you are going to have 15 subtract 50 from 63, that is minus 13, subtract 48 from 48, that is 0, 90 minus 90, that is 0, then 0 minus 0, that is 0, 0 minus 36, that is minus 36, and 0 minus 3, that is minus 3. Now you have gotten the pj minus zj. Don't forget that for us to obtain optimal solution, our pj minus zj must be less than or equals to 0. Now if you look at the pj minus zj in this place, you will realize that all of them is less than or equals to 0. As you can see, minus 13, 0, 0, 0, minus 36, and 3, minus 3 rather. Therefore, we have already attained an optimal solution at this point. And the value of the resources that we make use are 48 and 90. 48 of x2, that is 48 of x2, 48x2 plus 90x3, that is 90x3. Now, we don't have x4 in our real variable. We don't have x4 in our real activity. Therefore, we are not going to be including x4. Now, these are the resources that we make use to produce the optimal output. That is 48 of x2 and 90 of x3. That is how to calculate linear programming problem. That is how to solve linear programming problem using the simplex method.
On this channel, you will find information, concepts explanation, tutorials video with detailed explanation that will assist you in gaining more knowledge and insight. In addition, our channel features past question, solution to questions you are likely to encounter in exam, solution to all past questions. Please kindly subscribe. All questions